Welcome back. In the last lesson, part one of derivative basics, we talked about what a derivative is. We talked about slopes of tangent lines, equations of tangent lines, the difference quotient, definition of derivative, where those formulas come from, how they're represented. We did a few examples with some basic polynomial functions. Now it's time to get into some ugly ones. So in this number 5, we're dealing with not just a plain polynomial, but rather a reciprocal function. This would be the graph of a hyperbola. The algebra is a little bit more intense than that, so let me show you kind of how something like that works. Now again, we're looking for the equation of the tangent line, not just the slope. So if you remember, that's y minus y1 equals m, or m tan, slope of the tangent line, x minus x1. Now the cool part is the x1 and y1 are both given, so I can fill those in right now. All that remains for us is to find our f prime. So let's see what we can do about that. Now our f of x was 1 over x. To find our slope of the tangent, that's our f prime, which is the limit as our horizontal displacement approaches 0, or horizontal distance between the points as they get really, really close. F of x plus h minus f of x all over h. So that's going to give us, to find f of x plus h, all I really do is just replace the x with x plus h. So instead of 1 over x, I'm going to have 1 over x plus h minus f of x is the equation as it is, 1 over x, and then all over h. Now, to deal with this top, it's really just some basic algebra. I'm going to multiply both terms by 1. It's just how I choose to write the 1 is different in each case. So in essence, I'm looking to give them common denominators. So in this first one, I'm going to multiply the top here. X times 1 gives me x. And I'm just going to leave this bottom, x plus h times x. I'm just going to multiply the 1 and then just leave the negative out of my second fraction for now. And then the same denominator. Just takes me to here. From there, I get limit h approaches 0. Now I can take these two fractions and combine them together. So I get an x. Now I'm going to distribute that negative in. Minus x minus h over x times quantity x plus h all over h. Now the cool part of this is those two x's are going to cancel, leaving me with limit h approaches 0, negative h over x times x plus h. Now I'm going to cheat a little bit here. Technically, when you divide by h, you're dividing by h over 1. And since I am dividing by h over 1, I know that's the same as multiplying by 1 over h, which will reduce quite nicely in our derivative formula, leaving me with a negative and a 1. So I get negative 1 over x times x plus h. Now we can go ahead and actually substitute that 0 in for h, giving me negative 1 over x times x plus 0, which gives me negative 1. X plus 0 is x times x is x squared. So our f prime of x is negative 1 over x squared. Now let's take that back here. So in our first one, f prime of x was negative 1 over x squared, but I need f prime of 1. So instead of the x on the bottom, I'm going to replace it with a 1, which gives me negative 1. And there is our first tangent line. Now our second equation, well, again, y minus y1 equals the slope of our tangent line times x minus x1. This time all I'm given is the 4 here for x1. So I guess the first thing I'd like to find is the y. Now remember from the last video that when you plug into f prime, you get your slope. I'm not looking for my slope, I'm looking for my coordinates, so I need to find f of 4. I need to plug into f of x to get my y value, and square root of 4 is 2. So y minus y1 is now y minus 2. Now we're left to find f prime this way. So f of x is square root of x. Hopefully from your Algebra 2 and your pre-cal, you learned about rational exponents, and that is x to the 1/2. We may use that, we may not. We'll see kind of how it goes. So our f prime is going to be, again, f of x plus h minus f of x all over h. I think I'm just going to leave it here in the square root form, and excuse me, and if needed we can use the 1/2 power if necessary. That's going to come in, the 1/2 power will come in a lot nicer when we're doing things like the power rule and stuff with rational exponents and square roots. But so my f of x plus h will be square root of x plus h minus my initial function f, which is just square root of x all over h, and that's a limit as h approaches 0. Now, if I were to plug in 0, that'd be both here and here, what's going to happen is that's going to give me that 0 over 0 form, that indeterminate form. So you can say, okay, let's factor. Have a good time with that. That's not going to probably work well. What I'm going to choose to do is something a little irregular here, in that I'm going to rationalize, but you guys are probably in your algebra classes used to rationalizing the bottom. I'm going to rationalize the top by multiplying by its conjugate. So since the top is root x plus h plus, or minus x, I'm going to multiply by root x plus h plus root x. And the only one I'm going to mess with is the one where I'm trying to rationalize the top. The bottom I'm going to leave just like it is, and you'll see why here in just a minute. Yeah. So again, when you're doing conjugates, like if I'm taking a plus b times an a minus b, that gives me an a squared. I know that the middle terms, the outer and inner, are going to cancel. So I just get the a squared minus the b squared. Same thing here. I do not have to distribute the whole thing because I know that since they are conjugates, this outer and this inner are going to cancel. So I just do the firsts, and basically root x plus h times root x plus h is just x plus h, and then root x times root x is minus x. So those will cancel quite nicely for me. And then let me go ahead and erase a little bit here. That's going to take me to limit as h approaches 0 of h over h times root x plus h plus root x. Now you can see why I didn't cancel, or why I didn't distribute that bottom, because you should see that there's an h on top being multiplied, or on the bottom there's an h being multiplied here. So that leaves me with limit h approaches 0, 1 over root x plus h plus root x. Now I'm not going to get that 0 over 0, that indeterminate form again. I can actually get an answer here. And then we plug in our h, so that's going to be 1 over square root of x plus 0 plus square root of x, which is 1 over root x plus root x, or 1 over 2 root x's if I combine my like term. So then if f prime, or was the function f? Yeah, it was f. We're going to look to find the value at 4. So if f prime of x is 1 over 2 root x, then our tangent slope is going to be 1 over 2. Again, we're looking for it at 4, which is 1 over 2 times 2, or 1/4. And from there, we can go back and we're done here too. Just gives you a little bit of practice on your algebra is all. Okay. Go ahead and practice a little bit here. If you wish, feel free to pause the video, come back to it when you're ready. And if you're back, the only thing I know is that my x-coordinate is -3, so minus a -3 is really +3, and that's pretty much what I got. So then, where do I go from there? Well, I'm going to write down my equation. It's x cubed, so x cubed minus 5x squared. This is my f of x. Plus 7x plus 8. Now again, if you'd like, you can do this with the definition of the derivative. You know, the limit as x approaches x initial, f of x minus f of x initial over x minus x initial. I'm just going to go ahead and practice doing my difference quotient. So that's going to give me f of x plus h minus f of x all over h. And that's going to give me, to do f of x plus h, this one's going to be fun, folks. Let me go ahead and do that where I'm going to have some more room to write here. Nah, let's just stay here. So that's going to give me x plus h cubed minus 5x plus h squared plus 7x plus h plus 8. Again, not forgetting my limit as h approaches 0. And then minus my original f of x, which is x cubed minus 5x squared plus 7x plus 8 all over h. Now, the cool part is I know all of these are going to cancel in due time. It's just going to be a little nasty getting there. So a couple of techniques I can show you. First one, to do x plus h cubed, that's x plus h times x plus h times x plus h. You can basically distribute those and get x squared plus 2x h plus h squared, and then distribute it by that again. And it's a colossal pain in the neck. So I'm going to show you a little thing called Pascal's triangle. It makes doing these binomials kind of cool, actually. Again, Pascal's triangle looks something like this. To find each term, it always starts with a 1. And then if you take this 1 and this 2 and add them up, in the middle is 3. 2 plus 1 is 3. And then 1. This would be x plus h to the 0 power. X plus h to the first, which would be 1x plus 1h. Here is x plus h squared. 1x squared plus 2xh's plus h squared. And then this is actually x plus h cubed. Let me walk through how that's going to look. So that gives me limit as h approaches 0. The 1 stands for the highest power of x I'm going to have. So it's x cubed. The 3 means I'm going to drop, well, first of all, I'm going to write the coefficient of 3. I'm going to lose an x. So instead of x cubed, I'm now at x squared. And I'm going to add in a power of h. This 3 is the same thing. I had 3x squared, lose a power of x, add a power of h, and then this 1 is just h cubed, which is exactly what you'd get if you were to distribute that, well, 2 or 3 times, whatever the case may be. Now, that's just doing the cubed part, which I know made you happy. So, and again, like I said, this is going to get long. Minus 5, and then we already know that x plus h, the quantity squared, is x squared plus 2xh plus h squared plus 7x plus 7h plus h. Now that is only this whole thing right there, that's just f of x plus h. Isn't that lovely? We've still got to, I'm going to do this in a different color so you can tell where they're at here. Let's go ahead and use this black here. So now I distribute, that's going to be a minus x cubed, a plus 5x squared. And don't worry about these so much because they're all about to cancel if I've done my mathematics correctly, and we'll find out soon enough. The 8's are history, 7x's are history. If I were to distribute that, that is negative 5x squared minus 10xh minus 5h squared. So the 5x squareds are gone, and then the x cubes are gone. So that helped a little bit. Let me go ahead and do some more writing here. And erasing, I guess, as the case may be. So that's going to give me the limit as h approaches 0. Let's see what didn't cancel. Well, I'm left with a 3x squared h plus a 3xh squared plus h cubed. I still got a negative 10xh, a negative 5h squared, and I think a 7h. I believe that's what's left, all over h. Do you see how the opportunities to do very bad things algebraically kind of pop into play here? Now, every term has an h in it, so I'm going to factor out an h, leaving me with 3x squared plus 3xh plus h squared minus 10x minus 5h plus 7 all over h. The h's cancel. I promise there's a light at the end of the tunnel here. I mean, the tricky part of this one was doing that f of x plus h term, because that cubed really added a little degree of difficulty to it. If you need me to in class, I can kind of walk you through that whole Pascal's triangle again. It's really cool for, like, if I would have had like an x plus h to like the 7th power, there is no way on this earth I want to sit there and FOIL x plus h 6 or 7 times. Not fun at all. So what I'm left with then is I'm going to go ahead and actually evaluate the h in here. So that's going to give me a 3x squared. And every term with an h in it, this one, that one, and that one, since h is 0, they're going to 0 out. So I get 3x squared minus 10x plus 7. So my f prime of x is 3x squared minus 10x plus 7. What are we looking for? We're looking for that at -3. So I need f prime of -3 is, bear with me as I write here, -3 squared is 9 times 3 is 27 plus 30 plus 7. That's 34. I believe that's 64 if I'm not mistaken. Pretty steep line is what that amounts to. Let me go back and take one last look at that just to make sure. Yeah, it's legit. Okay. And then we also need to find f of -3 to get our y coordinate. It's -27. -3 squared is 9 times -5 is -45 minus 21 plus 8. So let me see what that is. That is -72 minus 21 plus 8. That is -93 plus 8, which gives me a y coordinate of negative. So that's -85, I believe, which is going to turn this negative here into a plus 85. So pretty algebraic intensive here. Again, next lesson I'll show you the power rule, where the power rule comes from, show you a proof of the power rule. It'll make your life a lot easier. Okay, let's talk about a couple of things here. I'm going to talk about average rate of change, which is the slope of your secant line, which is y2 minus y1 over x2 minus x1. So when you're doing all those slopes in Algebra 1, you're doing a slope of a secant line. So in this case, since I'm doing it at 3 and 5, I can actually write that slope of the secant here, or my average rate of change, if you want to call it that. I can call that my y2, which is going to be f of 5, minus my y1, f of 3, over 5 minus 3. Now on the bottom, that's going to be easy. That's going to be a 2. Let's go ahead and find our two y values. So for f of 5, I'm going to replace that with 5. That's 5 squared plus 1. That's 26. minus f of 3. 3 squared plus 1, that's 10. So I get an average rate of change of 16 over 2, or 8. Easy peasy. Now the next one, going to make me work a little bit. We want the instantaneous rate of change. So basically, I want to know the value, not f of, I want to find f prime, and then plug in -4. Now we've been doing, so our f of x was x squared plus 1. I can do this with difference quotient just like I did before. In this case, since I'm only finding the derivative at this one value, maybe you might find it easier to just use your definition of the derivative. It's kind of your choice. So I will need to know a y value for that, so I am going to take f of -4, which is -4 squared plus 1. 16 plus 1 is 17. So in other words, this equation right here is going to have the coordinates of -4, 17. So this is x initial. This is f of x initial. That'll make things a little easier for us. So -4, 17 is our x initial, f of x initial. So to find f prime, again, this time I'm going to use definition of the derivative, which is limit as x approaches x initial, f of x minus f of x initial, which we know is 17, over x minus x initial, which we know is -4. So I get limit x approaches our x initial -4, since we're going to be finding f prime of -4. So f of x is going to be x squared plus 1 minus our y term for x initial, 17, over x minus -4, which is plus 4, which gives me limit x approaches -4. That's x squared minus 16 over x plus 4. Again, plugging this in is going to give you your indeterminate form. So let's go ahead and factor difference of squares, x plus 4, x minus 4, cancels with the x minus 4, or x plus 4 on the bottom, giving me limit x approaches -4, x minus 4, which gives me -4 minus 4, -8. And that is my instantaneous rate of change. So instantaneous, tangent slope, average rate, secant slope, the stuff you learned how to do in your Algebra 1 and Algebra 2 and stuff class. Okay. Let's finish it with some graphical representations here. Now, f of 2 basically means as I go here where x is 2, go to where I hit the graph, and my y value at that point is 2, nothing to it. Again, basic algebra stuff that you already, I hope, should know. Now, average rate of change, remember, this is just your secant slope, which is y2, or let me write it like this. It's your change in y over your delta x. So from 2 out here to 10, I can take these coordinates, which are 2, 2, and 10, I believe that's 7. I can run them through the y2 minus y1, all that stuff, and I can get my average rate of change quite nicely by doing that. But since it's nice and on a graph, and forgive me, my secant line is dreadful. But to get from point to point, I see my rise goes up 1, 2, 3, 4, 5, up, and then 1, 2, 3, 4, 5, 6, 7, 8 to the right. So I have a slope of 5/8. That is my secant slope. That is my average rate of change. Instantaneous rate of change. That's another ball game altogether. Now you might say, well, I don't know what that equation is. Is that like a square root function? I think that's actually a logarithmic function, and I'm not really anxious to play with this that way. We're going to approximate this average rate of change, or this is m tan, or instantaneous rate of change, I'm sorry. I'm going to go here. I'm going to go where my t equals 2. Now again, I know that's m tan, which means I need a slope of a tangent line. So I'm going to kind of do my best to draw a line. This is probably not going to be pretty. That's about as good as I can do. And since I do lack in the artistic world here, I'm going to go with this being approximate. You are going to be given a little leeway. So it looks like it crosses at a point here. So what do I got? I go up 1, 2, 3 over 2. So I basically kind of freehand. If you had a ruler or something, it might be a little better, but I can say that my instantaneous rate of change is about 3/2. If you say, well, I do it a little different and I got 2, that's okay. Now, if you said you got like -7, I think we got a problem. It's like you should be getting a slope here for your tangent that is both positive and then also probably greater than 1 also. So no problem. You say, well, what does it mean to find f prime of 2? F prime of 2 is also 3/2, or approximately 3/2. F prime is the same as your m tan, which is the same as your instantaneous rate of change. Specifically, we're looking for that tangent line, that local linearity at x equals 2. And I hope this helped you a little bit, and we'll talk in class.